Hey guys, here is the last lesson of the year. We are talking about sample z-scores. So the last time we got together, we talked about population z-scores that were not going to be whole standard deviations away from my mean. Today we're going to use sample z-scores, so data from a sample, and that we're going to be able to use that sample information to be able to reject or accept a null hypothesis. So last time we talked about accepting, rejecting, we kind of looked at, or we did look at box plots and looking for a drastic difference or basically the same. Now we're going to have like an actual number that tells us if they are basically the same or drastically different, like what's considered different, okay? So if our sample z-score does not fit within the middle 95% of the population data, then it's going to be considered too far away. So if it has a z-score of 1.96 or negative 1.96, if it's above that or below that, then we're going to be able to prove that we have the evidence to reject. If it's exactly 1.96 or negative 1.96, then it's just on the fence. It's okay. We can keep it. Okay, so it's only if it's in these little tails on the side. Okay, so a sample z-score is different than the z-score we worked with last time. So if this blue is what I just said, so x with the bar on top is our sample mean, subtract my population mean, then we're going to divide it by my standard deviation divided by the square root of my sample size. So I will say when you type this into your calculator, parentheses are a big deal. So when you type it in, I would do parentheses, do your sample mean minus your population mean, parentheses divide, parentheses, standard deviation, divide by the square root of your sample size like this. So make sure you plug it in with parentheses, otherwise you're not going to get the correct value out of it. So if you have a graphing calculator, you can plug it all in all at once. Just make sure you have a parentheses around your numerator and parentheses around your denominator as you do it. All right, here we go. So I actually have a little video to show you kind of an example of how we're going to do the following problems and how we're able to accept or reject. This video is 4 minutes long. Here we go.
I'm going to talk about hypothesis testing and the example we did in class, works for all statistics classes actually. So we took data from rats and alcohol. We fed alcohol to pregnant rats to see the effect on its pups. Since psychologists have been working a long time with rats, we know that the average weight of a baby rat is 18 grams. This is pups whose mommies didn't drink. The standard deviation is 4 grams. That's a symbol for standard deviation, and we also call it sigma. All this data on the left-hand side, this is about the population. Again, baby rats whose mommies didn't drink alcohol. The sample mean is 15 grams, with a sample size of 16. Now we're going to take this data and form a hypothesis about it. We say the null hypothesis, feeding alcohol will have no impact on birth weight of pups, and the mean will not be significantly different than 18 grams. And the alternative hypothesis says the mean will not be equal to 18 grams. And what we're going to do is we're going to calculate the z-score of the sample now. We're going to get everything set up, and the very first thing we do is we draw a little bell curve. We put the z-scores in. Remember, the z-score, the mean is 0. And we say 1.96 on the upper bound and negative 1.96 on the lower bound. I'm just providing this to you, but if you looked in a normalized table at the back of a typical statistics book, you'd find information like this. Remember, the whole area of the curve is 100%. So the area to the right of 1.96 is 2.5%. And the area to the left of negative 1.26 is also 2.5%. Now we can determine our rejection region. It's the red area to the left of negative 1.96, and to the right of 1.96 we have a two-tailed test. If we get any score within the z, we fail to reject the null hypothesis. And if we get any score less than negative 1.96 or more than 1.96, we reject the null hypothesis. Any z-score in the green area we could have obtained just by random luck, by picking some sample of smaller rat pups. Now when we calculate the z-score, we take the standard deviation of the population, and then we have the z-score formula set for on the right-hand side of the screen. The mean is 15 grams of the sample, and the sample size is 16. Now you just plug and chug, so z is equal to 15, and that's the 15 grams of the sample, if you look to the left, that 15 right there, minus the population mean, which is 18, that 18 right there to the left, the yellow, divided by the standard deviation of the population, which is 4 grams, look to the left again, the yellow, divided by that by the square root of the sample size of 16. Well, to math correctly, you should get a z-score of negative 3. Negative 3 would line up to the left of negative 1.96, so just about right there. So we say negative 3. So now we reject the null hypothesis. And we also then we say there's evidence feeding alcohol to pregnant rats reduces the birth weight of its pups. And that's just been a little video of what we discussed in class.
Alright, so now we're going to do some examples of our own. These first couple don't have any context with them yet. We're just getting the results of an experiment in the sample, and we're going to see if we have enough evidence to reject or keep whatever the null hypothesis was. So for this first one, we have a sample score or sample mean of 110, a population mean of 100. We're going to divide that by our standard deviation of 15 over our square root of our sample size, which is 49. Remember, those parentheses matter. When you plug it in exactly as you see it, parentheses and all, we're going to get a z-score of about 4.67. So this is our sample z-score. And that's going to fall up here, 4.67. So looking at where it is, my z-score is definitely bigger than that 1.96, right? So we are going to have enough evidence. We have proven there was a drastic difference between whatever the population and the sample was, whatever the claim was being made. We have enough evidence to reject the null and prove that there was evidence of the alternate hypothesis. All right, one more together. All right, we have a population mean of 10, a sample mean of 12, standard deviation is 5, sample size is 16. Don't fall for the tricks. It is sample minus population. So watch out. Sometimes they don't give it to you in order, so make sure you know how to put it in order. And then standard deviation over the square root of my sample size. Again, type it in as you see it, and this time we're going to have 1.6 as my sample z-score. All right, so 1.6 is going to fall pretty close to my boundary, but it's not going to be past it. It is still within my middle 95%. So we are not going to be able to reject the null hypothesis, okay, because we do not have enough evidence. And that's because my sample z-score of 1.6 was less than that upper boundary of 1.96. Right? Well, technically it's in between the two boundaries. So we can say between negative 1.96 and positive 1.96. So it's in between the boundaries, which means we're in between the 95%. So we do not have enough data, do not have enough evidence to prove that there was a difference. Okay? So now I would like you to pause the video, and you're going to try this one, and then come back and check your answers. All right, let's check your answers. So for this one, here we go. So we have a population mean of 1015, a sample mean of 1,000, a standard deviation of 19, and a sample size of 121. Again, be careful of how they give you the information. It's not always in order. You should set it up as 1,000 minus 1015 over 19 divided by the square root of 121. We get a sample z-score of negative 8.68, which is way below our lowest boundary. So we definitely have enough evidence to reject whatever the null hypothesis was that went with this problem. All right, so that was just the calculation part and the analyzing part. Now we're going to actually apply some context to our numbers. Okay, so this first one, so what's going to have is we're going to have someone making a claim and then someone thinking it's different. So we're going to see, is the original claim true? That's going to be the null hypothesis, or the alternate hypothesis is going to be what someone else thinks is different. Okay. So for this one, for the past 5 years, a test prep company has claimed that it can boost SAT scores to an average of 1,800. This is back when SAT scores, by the way, back in when I was in high school, they were out of 2,400 because the writing portion was required. So that's why these numbers might be a little bit off for you. So the past 5 years, a test prep company claims that it can boost the SAT scores on an average of 1,800. So that is the null hypothesis. That's what the company is claiming that they can do. Okay, but a researcher thinks that the average is going to be lower. So that's my alternate. The alternate is that it's going to be lower than the 1,800. Okay, so we're seeing, is there proof that it's actually going to be lower? All right, in a random sample of 36 students, that's my sample size, who took the course, their average was 1745. So that is the sample mean with a standard deviation of 210. My population mean is what the company is originally claiming. Do we have evidence? So let's see. All right, so we're going to do my sample, which is 1745, minus our population, divided by standard deviation over the square root of my sample size. All right, let's see here. Again, type it in with parentheses so that way your calculator does it in the correct order. I have a z-score of negative 1.57. So, draw my boundaries back down here. Negative 1.96, positive 1.96. This was my keep region. These were where we're going to have the evidence to reject. So to get a z-score of negative 1.57, that's going to be about right here. Okay, so negative 1.57 is less than negative 1.96, right? It's below that lower boundary. So we do have the evidence to reject the null. So what we can say here is that we're going to reject the null. Oh, we don't. No, we don't. No, we don't. Hold on. I'm losing it. I'm losing it. It's not below the boundary. It's in the middle. I apologize. Sorry. Our z-score was in between them. I apologize, guys. There we go. It's in the keep zone, isn't it? So it's in the keep zone. We do not have the evidence. Okay, we don't have an evidence to reject the null, so we have to believe that their null is true, that they do get their test, that their students who take the test prep class can get their average score of 1,800 on the SAT. Again, this is back when SAT scores were at 2,400. All right, let's do one more together before you do one. Here we have last year the same test prep company claimed that its private tutoring can boost SAT scores up to an average of 2,000. Again, this is when it was out of 2,400 because you had the math, you had the reading, and you had to do the writing of the essay. A researcher thinks that the average is higher than 2,000. So that's what they think is going to happen. The alternate hypothesis, they think it's going to be above a test score of 2,000. Okay, so that's going to be the so my population mean is the 2,000, right? In a random sample, here we go, of 49 students, they had an average of a 20/90, so that's my sample average, with a standard deviation of 150. So let's see, do we have enough to reject? So z-score, we have our sample minus our population over standard deviation over the square root of our sample size. So let's see here, 20/90 minus 2000. All right, I'm getting a z-score this time of 4.2. So to get my z-score, again, I should do this first. I am very visual, so I like to see my keep and my reject regions just so I keep myself square, because obviously we saw the last problem and that doesn't help me sometimes. All right, 4.2 is going to be up here, right? That is in the reject region. So since my z-score was bigger than 1.96, we do have the evidence to reject the null. So what does it mean to reject the null? To reject the null means we get to accept the alternate hypothesis, especially since my z-score was so high up. That means we can accept the alternate hypothesis, which means that students with private tutoring are actually going to get above the SAT score of 2000. All right, so to reject the null means we get to accept what someone else is claiming. All right. All right, last one. You are going to do this one on your own. Let me know about the tax preparer. The tax people claim they're going to give you a refund of $3,000, but the clients think that they're actually going to get less. Okay, so they think they're going to get, where is it? That it may be lower than. So my alternate is that the tax refund is going to be less than that $3,000. All right, so set it up, find your z-score, and come back and see how you did. All right, welcome back. Let's check our answers one final time. All right, so this time, so again, we said that the average tax refund, they are, the alternate is that's actually going to be less than the 3,000 that they are claiming. When you find your z-score, you actually get a sample z-score of negative 8.43. That is way, way lower, right? That is way in the region. So because of that, we do have an evidence. So we are going to accept the null hypothesis, the alternate hypothesis. So we will reject the null. Okay. So my average my average tax refund is not going to be $3,000. It is actually going to be way less. So we're going to accept this one. That is going to be less than the 3,000. All right. So that is it. No more Algebra 2. Well, no more new lessons. So good job today. Let me know if you have any questions. Reach out to me. Please complete the assignment today, and then we will test in the near future. So again, let me know if you have any questions. If not, then I will see you next time. Thanks. Bye.